ተማሪዎች እንዴት ናችሁ? ስሜ ብሩክ አለሙ ይባላል። በአዲስ ከተማ መሳናዶ ትምህርት ቤት የኬሚስትሪ መምህር ነኝ። ተማሪዎች እንዴት ነው? ቤት ተቀምጣችሁ ምን እየሰራችሁ ነው? እርግጠኛ ነኝ እያነበባችሁ እንደሆነ። ስለዚህ ቤት ተቀምጣችሁ ብዙ ነገሮች ማድረግ ይኖርባችኋል። ጊዜያችሁ ዝም ብላችሁ ማቃጠል የለባችሁ። እንደ 11ኛ ክፍል ደግሞ ተማሪ ለ12ኛ ክፍልም የ11ኛ ክፍል ትምህርት 50% ስለሆነ በቂ የሆነ ዝግጅት ማድረግ ይኖርባችኋል። ስለዚህ ከኔ ጋር በ11ኛ ክፍል ኬሚስትሪ ትምህርት ላይ ጥሩ ቆይታ ይኖረናል ብዬ አስባለሁ። ስለዚህ እናንተም በትኩረት ክፍል ውስጥ እንዳላችሁ አድርጋችሁ ትምህርቶች መከታተል ይኖርባችኋል። በመሃል የሚጠየቁ ጥያቄዎች ይኖራሉ። ስለዚህ ከታች በሚጻፈው ድረገጽ ጥያቄ መጠየቅ የምትፈልጉትን እንደሚጠየቃችሁትን ጥያቄዎች መመለስ ይኖርባችኋል። ስለዚህ ተማሪዎች ዝግጁ ናችሁ? ናይስ። ስለዚህ ወደ ትምህርቱ እንገባለን ማለት ነው። ዩኒት 3 Unit 3 Chemical Bonding and Structure. Chemical Bonding, Chemical Bonding and Structure. Chemical bonding and structure. Students, what is chemical bonding? What is chemical bonding? Okay. The force of attraction. The force of attraction. The force of attraction that hold atoms. The force of attraction that hold atoms together. The force of attraction that hold atoms together are called chemical bonds. Chemical bonds. The force of attraction that hold atoms together are called chemical bonds. There are two types of electrostatic forces. There are two types of electrostatic forces. One is intramolecular forces. The other one is intermolecular forces. Remember, chemical bond is a force of attraction that hold atoms together are called chemical bonds. There are two types of electrostatic forces. One is what? Intramolecular forces. The other one is intermolecular forces. Intra and what? Intermolecular forces. These chemical bonds are under intramolecular forces. The force of attraction that hold atoms together are called chemical bonds. These chemical bonds are categorized under what? Intramolecular forces. Categorized under intramolecular forces. Therefore, these intramolecular forces affect the chemical properties of the species. These intramolecular forces affect the chemical properties of the species. Intermolecular forces affect the physical properties of the species. Types of chemical bonding. Types of chemical bonding. 1. Ionic bonding. Ionic bonding. 2 is what? Covalent bonding. Covalent bonding. 3. Metallic bonding. Metallic bonding. There are two types of electrostatic forces. One is intramolecular force, the other one is intermolecular forces. These chemical bonds under intramolecular forces. Therefore, there are three types of chemical bondings. One is ionic bonding, 2 is covalent bonding, 3 metallic bonding. Students, what is ionic bonding? What is ionic bonding? Okay, one is what? Ionic bonding. Ionic bond is formed by electron transfer. Electron transfer. Student, electron transfer. Metal to non-metal or non-metal to metal. Because ionic bondings are under chemical bonds. This ionic bondings are, it is formed by electron transfer. This electron transfer is metal to non-metal or non-metal to metal. Okay, therefore, is formed by electron transfer metal to non-metal. With different electronegative values. There are three types of chemical bonding. One is ionic bonding. Ionic bonding is formed by electron transfer metal to non-metal. Therefore, ionic bonding is formed by electron transfer from a metal to a non-metal. Metals are losing of electrons, non-metals are gaining of electrons. Therefore, transfer of electrons takes place from metal to non-metal is known as ionic bonding with different electronegative values. With different electronegative value means, by the way, what is electronegativity? You know electronegativity in chapter 2. Electronegativity is what? The power of the atom to attract a shared pair electrons. The power of the atom to attract a shared pair electrons. You know the three most electronegative elements, fluorine, oxygen, and nitrogen. Therefore, with metals and non-metal, there is a different electronegative values. Between two electron different value element, metal with non-metal, a bond is formed. That bond is ionic bonding. A bond formed by metal with non-metal is known as, a compound is known as what? Ionic compounds. Examples of ionic compounds. Examples of ionic compounds. First, you know compound. Compound means a combination of at least two different elements. Ionic compounds are a compound. That compound is formed by metal with non-metal. Ionic bonds are formed. That ionic bond is formed. The compound is known as ionic compounds. Examples of ionic compounds. Sodium chloride. Because sodium loses one electron, chlorine accepts one electron. You know sodium is group 1 element, chlorine is group 7 element. Transfer of electrons takes place sodium to chlorine. Sodium loses one electron, chlorine gains one electron. Therefore, sodium chlorides are ionic compounds because it contains ionic bonds. Another example, potassium fluoride. Potassium fluorides are ionic compounds because potassium is group 1, fluorine is group 7, halogen. Between these two, a bond is formed, ionic bond. The compound is known as ionic compounds. From group 2 elements, for example, calcium fluoride. Calcium fluoride. Because calcium loses 2 electrons, each fluorine accepts 1 electron. Therefore, calcium fluorides are ionic compounds. Another ionic compound, magnesium chloride. Magnesium chlorides are ionic compounds. A transition element, for example, scandium bromide. You know transition elements are metals. Scandium is atomic number 21. Scandium is the first transition element, atomic number 21. Therefore, scandium bromides are ionic compounds. Iron, FeCl2. Iron, FeCl3. Ionic compounds. Zinc chloride. Ionic compounds, and so on. Okay, properties of ionic compounds. Properties of ionic compounds. Properties of ionic compounds. What is the properties of ionic compounds? You know ionic compounds. A compound that contains ionic bond is known as ionic compounds. Crystalline solids at room temperature. Crystalline solids at room temperature. Ionic compounds are crystalline solids at room temperature. The fundamental units are the fundamental units are positive and negative ions. Look, this is the property of ionic compounds. One is crystalline solids at room temperature. Ionic compounds are crystalline solids at room temperature. The other property, the fundamental units of ionic compounds are ions. What types of ion? Positive and negative ions. Cations and anions. For example, calcium chloride. Calcium contains positive charge. Chlorine contains negative charge. Sodium fluoride. Sodium is positive charge. Chloride is negative charge. Therefore, the fundamental units of ionic compound or all ionic compounds are contains positive and negative ions. This is another property of ionic compound. The other properties of ionic compounds are crystalline ionic compounds are not conduct electricity. Crystalline ionic compounds are not conduct electricity. Why? Because it contains ions, positive and negative ions, but positive and negative ions are not freely moving. Therefore, ionic compounds in solid state or in crystalline form, ionic compounds not conduct electricity. Ionic compounds in solid state not conduct electricity. But ionic compounds in molten state or in aqueous solution conduct electricity. Remember, ionic compounds in solid state not conduct electricity. Why? Because cations and anions are not freely moving. But ionic compounds in molten state or in aqueous solution, you know, aqueous water, in aqueous solution conduct electricity. Why? Because cations and anions are freely moving. Cations and anions are freely moving. This is another property of ionic compounds. The other one, ionic compounds are high melting and high boiling points. Ionic compounds are high melting and high boiling points. Ionic compounds non-volatile. By the way, why ionic compounds are non-volatile? Because ionic compounds are exist in which state? In solid state. Solids are in volatility low. High volatility is gas, next liquid, then solids. Therefore, most or ionic compounds are solids. Because of that, ionic compounds are non-volatile. And finally, ionic compounds are very resistant to heat, but easily broken by water. Therefore, ionic compounds are very resistant to heat, but easily broken by water. This is all about ionic compound properties. Crystalline solids at room temperature. The fundamental units are positive and negative ions. Ionic compounds in solid state not conduct electricity. Ionic compounds in aqueous solution or in molten state conduct electricity. Ionic compounds are high melting point, high boiling point. Ionic compounds are non-volatile. Ionic compounds are very resistant to heat, but easily broken by water, easily soluble by water. Most of ionic compounds are soluble in water. Okay, 2 is covalent bonding. Covalent bonding. Students, what is covalent bonding? Okay, covalent bonding is formed by sharing of electron between two atoms. Covalent bond is formed by sharing of electron between two atoms. Usually 2 nanometers. Most of the case, by 2 nanometers, sharing of electrons takes place. The bond is known as covalent bonding. The compound that is formed by sharing of electron, the compound is known as what? Covalent compounds. Please, students, try the examples of covalent compounds. Okay, students. Example, H2O, NO2, HNO3, HNO3, carbon dioxide, SiCl4, silicon tetrachloride, SF4, SF6, PCl5, NH3, and so on. All this is an examples of covalent compounds. H2O, NO2, HNO3, CO2, SiCl4, SF4, SF6, PCl5, NH3 is an examples of covalent compounds, because all these compounds are formed by sharing of electron between two nanometals. And the representations of covalent compounds, by using of the representations of covalent bonding through Lewis symbols and shared electron pairs is called a Lewis structure. The representation of covalent bonding through Lewis symbols and shared electron pairs is called a Lewis structure. Look some examples of Lewis structure. For example, H2O. You know H2O is water. First write the number of atoms, hydrogen and oxygen. How many hydrogen? 2 hydrogen. Therefore, 2 times 1, 2. Why 2? Because the number of hydrogen is 2. Why 1? Because the number of oxygen is 1. 2 times 1 is 2. Oxygen, how many oxygen? 1 oxygen. 1 times 6 is equals to 6. 2 plus 6, 8 electron. This 8 electron is what? Total valence electrons. Total valence electrons for water is how much? 8 electron. The central atom is oxygen. Look, O. How many surrounding atom? 2 hydrogen. A bond is formed because one bond is 2 electron, another one bond is 2 electron, 2 plus 2 is 4, but total number of electron is 8. 8 minus 4, how much? 4. This 4 is 1, 2, 3, 4. The remaining electrons. This is 2 electron, this one is 2 electron. By the way, these 2 electrons are known as what? These 2 electrons are, thank you, lone pair. This is also lone pair. What about this one, student? Excellent. This is a bond pair. This one also bond pair. How many bond pair? 2 bond pair, 2 lone pair. Lone pairs are not participating chemical bonding. Therefore, 2 bond pair, 2 lone pair. Therefore, this is the Lewis structure of water. Another example, SF4. In this case, sulfur 1 times 6, because sulfur is group 6 element. 1 times 6, the number of sulfur is 1. 1 times 6, 6. Fluorine, how many fluorine? 4 fluorine. Therefore, 4 times how much? 7. 4 times 7, 28. Because fluorine is group 7 element. Now, the sum of 28 plus 6, 34 electron. This 34 is similarly total valence electron. Now, what is the central atom? Sulfur. Sulfur is central atom. How many surrounding atom? 4. 1, 2, 3, 4. Therefore, first forms a bond. 1, 2, 3, 4. How many bonds are formed? 4. Therefore, 1, 2, 3, 4. 4 means 8. 34 minus 8. The remaining electron is 26. This 26 electron, each fluorine requires how many electron? 6. 1, 2, 3, 4, 5, 6. 6 plus 2, 8. Satisfies the octet rule. Similarly, 1, 2, 1, 2, 1, 2, 6. 1, 2, 1, 2, 1, 2, 6. 1, 2, 1, 2, 1, 2, 6. Each fluorine requires 6 electron plus 1 bond pair. Total number of electrons is 8. Therefore, look, 6, 6, 6, 6. 6 times 4, 24. 26 minus 24, the remaining electron is 2. This 2 is for what? The central atom, sulfur. This is a Lewis structure of SF4. One more example. One more example is carbon dioxide. Carbon dioxide. In carbon dioxide, carbon is 1 times 4, 4. Oxygen 2 times 6, 12. Total is 16. What is the central atom? Carbon. Therefore, carbon is as a center, 2 surrounding atom, oxygen. This is a skeleton. First uses a single bond, 1, 2. 2 means 4. Therefore, minus 4, the remaining electron is 12, 16. 16 is total valence electron. 4 is 2 bond pair can be formed between carbon and oxygen, minus 4, 12. Each oxygen requires how many electron? 6. Therefore, look, 6, 6. But in this case, carbon do not obey the octet rule. Do not obey the octet rule. But carbon, by using of a double bond, satisfies the octet rule. Satisfies the octet rule. By forming a double bond. Therefore, a double bond can be formed. This 6 is converted into 4. Similarly, this 6 is converted into 4. Double bond can be formed. Therefore, carbon dioxide is look like this. Carbon dioxide, it forms a double bond. Carbon dioxide contains a lone pair. Again, carbon dioxide is a linear structure. Again, carbon dioxide it contains 2 double bonds. 2 double bond contains again 4 lone pairs exist in carbon dioxide structure. Students, please write the Lewis structure of the following molecules. One is HNO3, nitric acid. Please draw the Lewis structure of HNO3. 1, 2, CO3, 2 minus, CO3, 2 minus, carbonate ion, 3, N2O4, 4, CO. Please, students, try these questions. ተማሪዎች የዛሬው ትምህርታችን ይህንን ይመስል ነበር። ስለዚህ የተሰጣችሁን ጥያቄዎች ትንሽ ሞክሯቸው። ምናልባት እኔ የሰሯቸውና እዝጌ የሰጧችሁ አንድ አይነት ጥያቄዎች ላይሆኑ ይችላሉ። ስለዚህ እነዚህ ትንሽ ጠንከር ያሉም ጥያቄዎች ይኖራሉ። እነዚህ ሞክሩ። ከታች ባለው ድረ-ገጽ መልሶቻችሁን እንድትልኩልን እንፈልጋለን። ስላዳመጣችሁኝ አመሰግናለሁ። በቀጣይ ክላስ እንገናኝ።